Okay, so today we're going to go ahead and talk about how to find the voltage drop and current through each resistor in a circuit that is not just series or just parallel, but has components of both. Okay, so first what we're going to do is we're going to go through, I have some steps that we're going to go through together. So step number one, we're going to go ahead and simplify the circuit and redraw here. So if you look at this circuit, okay, so we have the voltage. So again, this is our battery, this is the positive side, and that's the negative side. Conventional current is the flow of positive charges, even though we know it's really the electrons that go. By convention, we say it's the positive charges. So those charges are going to go clockwise. So if you look at this, okay, initially there's only one resistor right there. There's only one pathway for the current to flow. So this starts as a series circuit. So we're going to need to use our rules for finding equivalent resistance or total resistance and redraw this as a series circuit. So it starts right here, but then the current splits. Some goes here and some goes here. So this 7 ohm and 10 ohm together, since the current splits, these two are in parallel to each other. So again, we know we're going to have to redraw the circuit as a series circuit because there's only one resistor to start and it starts as series. So we're going to go ahead and do that. So I'm going to go ahead and scroll out. Okay, so for this parallel part, we know that the total resistance, I'll go ahead and write it right here. So oh my goodness. Okay, so for this part, we know that for the parallel part, excuse me, oh my goodness, what did I get there? Okay, so that is going to go ahead and be, for this parallel part, 1 over R equivalent is going to be 1 over 7 plus 1 over 10. Okay, and when I go ahead and do the math, I get R equivalent to be 4.12 ohms once I simplify this completely. Okay, so again, those two, we're redrawing the circuit as a series circuit. So we know we have our 12-volt battery. So this is our 12-volt battery. And the first resistor is just a 5 ohm. So this is R1, which is just going to be a 5 ohm. And then we have a new resistor, which is essentially calling the 4.12 ohm. And again, that 4.12 ohm resistor is a combination of the 7 and 10 that we redrew as one series circuit. And then we have it right here. Okay, so now what we're going to do, we're going to go ahead and do step number 2. We'll find the total resistance and total current and put that in there. Okay, so we go ahead and look at this, and we just redrew a series circuit. So total resistance for series, we know, is we just go ahead and add it all up. So our equivalent is just going to be 5 plus 4.12. And so we know the total resistance is just 9.12 ohms. Okay, total voltage we know is 12 volts, and we know total resistance. How do you find current? Think about that. Okay, cool. We're going to go ahead and use Ohm's law. So V equals IR. So the voltage drop is 12. We want to go ahead and find the current, and the resistance is 9.12. Okay, so to solve for I, we can divide both sides by 9.12, and I got I to be 1.32 amps. Okay, so what I'm going to go ahead and do is I'm going to go ahead and put all this information that I know in the table. You do not have to use the table to sort out your information, but I think that is helpful. So again, I already knew the total voltage was 12 volts. R1 I know is 5 ohms. R2 was 7 ohms. And then R3 was 10 ohms. We just found the total current was 1.32. And then the total resistance we found was 9.12. Great. So we have all that information on the table. So now we're going to go ahead and go to step 3, which we're going to label the redrawn circuit with voltage and current for each resistor using our rules for parallel and series, and then we'll fill out the chart with additional info. Okay, so again, we're going to number 1, our redrawn circuit. So this is a series circuit. So I know in a series circuit, there's only one pathway for those electrons to flow, so the current is staying the same. So the current through each of these is just what I found for the total current, which is 1.32 amps. Okay, now on the redrawn circuit, I want you to find the voltage drop for each of them. Okay, great. Now that you found that, I'll go ahead and post the answer here. So again, I use V equals IR for each of these. So I is what, 1.32 times 5. And I got this to be about 6.6 volts. For the other one, same idea. I is what, 1.32 times 4.12. And I got voltage to be 5.44 volts. Great. So we're going to use this redrawn circuit to help us. But we know, so now if I look back on our circuit, so R1 is just the same thing as what we had in our original circuit. So we can fill out as much as we know about R1 in our circuit. So R1, the voltage drop for R1, oh my goodness, silly. I did a silly mistake earlier. I labeled this in the wrong column. Sorry about that. So the resistance, again, this is 5, this is 7, and this is 10. Okay. Oh my goodness, I got the resistance. Okay, everything else looks good. Sorry about that. Okay, so for this, so voltage drop for R1 is going to be 6.6, and then the current is going to be 1.32. Okay, got that right now. So now let's go ahead and look at step number 4. So step number 4 says use parallel series rules to break up resistor that represents 2 or more resistors and find voltage and current for each individual resistor and fill out chart with additional info. Okay, so looking at this, so this, I'm going to go ahead and highlight it. Will the highlights show up? Let's see. Okay, so these resistors right here, those are represented by the information right here. Okay, so those 2 resistors are in parallel to each other. So if they're in parallel, I want you to think about what stays the same. Is it current or voltage? Okay, it is voltage that stays the same in parallel circuits. So we know that the voltage drop through each of these is just going to be 5.44. So again, voltage drop is just 5.44 for each of these. So now we can go ahead and fill out that information in the table. So voltage drop is just 5.44, and this is 5.44. So anytime we know 2 things out of V, I, and R, we can find the other one. So let's just use for each of these V equals IR to find. So I'm going to go ahead and set up for the 3 ohms, so we can use V equals IR. Voltage is 5.44. I we want to find, and resistance was 10 ohms. Okay, divide both sides by 10, and I get 0.54 amps equals the current for the 10 ohm. So let's go ahead and put that in the table. Okay. So now let's go ahead and look at the other one. So for the 7 ohm right here, you will go ahead and use V equals IR. So the voltage drop, again, was 5.44. We want to find I, and the resistor is 7. Okay, to solve for this, divide both sides by 7, and I got I to be 0.78 amps. So I'm going to go ahead and put that on my table, 0.78. Okay. Okay, so now let's go ahead and look at this. So again, for this, so this, the 7 and 10 ohm, we had redrawn that as the 4.12 on the redrawn circuit. So let's go ahead and the total current we know is just going to be 1.32 for those 2 together. But let's see if this makes sense. So 0.54 goes down here, and 0.78 goes down here. If you combine those 2, 0.78 and 0.54, if I add those together, they get the 1.32, which means it would just recombine as 1.32 amps for the rest of the circuit. Cool. Isn't that a great way to check yourself? Great. So feel free to let me know if you have any questions on this problem.